the amount of energy that the electron had to jump between. If you saw purple light, ooh, that had to be a bigger transition. So, once you figured out the light, then you figured out the energy levels within the structure because you can't see them, okay? So, to understand, ironically, to understand electron structure, you have to understand light. So then that led to the idea is like, okay, well, how do we know they have spins? Like in the story, they talked about spin up and spin down. Cool. How they were able to accurately find that out is that once they developed even better light separation techniques, what they did is they found that red light, if you look at it and could separate it even farther, that red light is actually, there's a small difference in that. Because it looks like one, but if you can develop a better technique, you'll see that there's actually a very small difference in that spectrum. The only way that can be explained is if the electrons have opposite spins. So, I know here's the classic idea that everybody has of electrons. Like one spinning like this, and the other one spinning clockwise and counterclockwise. We have no unearthly idea what these bohemian electrons are doing. Okay, I just wanted to say the word bohemian because I think it's cool. So, we have no idea. It isn't like we can look at them and go, oh, we can see them spinning on their axis. No, okay? The only reason that we know their spin is because of the fact that once we developed that technique, we said, oh, okay, great. There's a small difference in that color. And the only way that can happen is if they have opposite spins. That's the only way they can figure this out. Now, and this is where you get into, they use the same technique, and this is where it goes back to the Doppler effect. Anybody remember what the Doppler effect was? Meow. Yeah, frequency changes depending on the relative motion, right? So what they began to do is they began to look at light that was emitted from distant galaxies. And what they found is that light from distant galaxies underwent what was known as the redshift, okay? So the redshift implies that these light, as it's being emitted, is getting spread out. The only way that can happen is just like a car that's driving away from you. A car that's driving away from you, the pitch is lower. The car that's approaching you, the pitch is higher. And if the universe wasn't moving, all the light would be the same because it would be stationary. And that's kind of what we thought. It's like, okay, hey, we're in a static universe, not a big deal. But then when they began to look at it, they said, ooh, this is bad, okay? Well, how do you explain this? That this light is getting shifted. And not only is it getting shifted, but the galaxies that are farther away are undergoing a bigger shift in their light, which means that those galaxies are even traveling away from us faster than the ones that are closest to us. So, oh, hello. I do. I'll do it. All right. Tyler, go. That was awful. So, all right. So here's the point of the story: is that we've learned so much from studying light, but that was a whole process. For example, why do we call helium helium?
Because helium.
Was it named
Helios?
after somebody?
Huh?
Was it named after somebody?
But helium.
You want your sock and tray to go up?
Yeah, I'll
Let's
take
see
a shot. Okay. Because it emits a yellow light that looked like the sun. We named the sun god Helios.
Kinda. That'll just keep you.
Just stay the same?
Yeah.
Alright, I'll take it.
About half right, half wrong.
I thought it was named after somebody.
So, this is just going to be this whole thing now. I want you to know the monster.
If we print off pictures of everybody's heads, will you like constantly move us up and down throughout your lectures?
Flip us up and down.
You should have to like.
Is everybody, okay, then let's dive this into quanta, okay?
Okay.
All right?
We're doing something fun.
Is everybody going to start at ground, is everybody going to start at the ground ground level energy state.
Cohen can start like one step below.
Like you'll start with negative?
Yeah.
No, I think everybody has to start the same. But we can, but you can only make quantum jumps though, okay? Right? So you're either here or you're here. Okay, they can't be like, it won't be like a slide. Okay? If we're to do it, that's what we gotta do. Okay. So, the reason helium is named helium, number one, why do you think it's incredibly difficult to ever discover helium gas?
It doesn't like to interact with anything.
Number one, it doesn't interact. Number
We
two,
don't have a lot of it.
we don't have a lot of it. That's why I said, so help me God, I go to any of your graduation parties, I see the first helium balloon, I'm out. Okay, and then I will yell at you as I go in. So, you might have to call security, I'm just saying. So, it doesn't interact and it's exceptionally rare. So, the reason that it's named helium is because the first time we saw that particular spectrum was when they were looking at the spectrum of light that was emitted by the sun, which is named Helios, okay? And so they said, ooh, there's a spectrum that we have never seen on Earth. So that led to the idea of like, what's powering the sun? Oh, hydrogen is fusing into helium. So the reason that there's helium in the sun is because that's a byproduct of the fusion process. So then when they actually were able to isolate the gas helium, which was incredibly difficult to do, once they got that isolated and they looked at that spectrum, they said, ooh, we've seen that before. We saw that in the sun. And that's how they figured out that there was helium in the sun, which didn't make any sense at all. It's like, this doesn't make any sense. Why is there helium in the sun? Why is there an inert gas in the sun? Which made no sense at all. But then Einstein comes along and says, whoa, whoa, E equals mc squared. That's how energy and mass are related. So a small change in mass multiplied by the speed of light squared gets you energy. So that's going to be the other side of the energy coin, which we will deal with Wednesday and Thursday. Okay, so here we go. I'm done. It's a relatively short assignment, but it's going to tie together some different things, including the photoelectric effect. All right,
Convince him that
this is all it took me to do. Okay?
Hydrogen balloons
Most of
instead
it's
of
multiple
helium.
choice.
We toyed around with that name.
What? What?
We toyed around with that name.
Yeah, did it work? No? Oh.
Hey guys,
Because we toyed around with the idea of trying to trick him by filling up balloons with hydrogen, and he said he would take a ladder over and try and pop them, and it might explode.
I mean, that's perfectly fine.
That's what exploded.
Yeah.
Like the perfect amount to like use up this year. Like I'm perfect. This causes me not to be perfect.
No hate.
I managed to run out somehow. I don't know how, I don't know when, but I did.
You want to fly it, and like, I don't know.
Kevin, hear me out. We just shoot a lot of protons into the hydrogen atoms. Make them into helium ourselves. Are we just achieve?
Make helium ions.
Now, if you made your own helium for the party, all was forgiven.
Create your own fusion reactors.
Yeah, fully.
BYOH, bring your own helium.
Yeah, just like, you know, just detonate a small fusion bomb like in your backyard.
Yeah.
And then you all
Okay, here we go.
Ask the government for some uranium. Just like get
No, you don't
some
need-
hydrogen bombs from the government.
So just like
No.
pull up the U.S.
You
government.
don't need uranium to create nuclear fusion.
Yeah. You gotta pull
You
up
just
the
shoot it
U.S.
at a very high
on
power.
Instagram and DM, hey, can you let me know? Can you let me borrow a fusion bomb to create some helium for my grad party? Thanks. My address is 815 Carriage Court. I know y'all are coming for me.
No, you're fine.
Write a letter to Trump.
Yep. Because otherwise, you
I
have alternating
perhaps
current.
borrow one of your nuclear warheads.
Yeah, just
I'm just trying to
throw a banger at a grad party.
throw a banger.
My address is 815 Carriage Court. I know y'all will be coming for me.
Oh yeah, me too.